Stig, explain every single button on the overhead of the 787. You asked for it. Here we go. Here's the info dump. Get ready. We're going to start at the bottom and then move our way up and down. First things first, the light panel. Now, a lot of this is self-explanatory, but component location is also important. Landing lights, runway turn-off lights, taxi lights, and strobes. These are the nose landing lights. The left and right wing landing lights are embedded into the root of the wing right there, which is also right next to the runway turn-off lights. Taxi lights are the smaller ones that are right next to the nose landing gear lights. The strobes are the blinking white lights. This is not to be confused with position lights. Position lights being the red, green, and white. Red on the left, green on the right, white on the tail. Up next, we got the wing lights. This is to illuminate the leading edge of the wing and the nacelle. Beacon is going to be the top and bottom red blinking light. The logo light is what's on the horizontal stabilizer, illuminating the vertical stabilizer. And as the name would suggest, illuminates the logo of the carrier. The little switch on the upper left corner, which says indication light test, that's an interesting one. It's got 3 settings: test, auto, and bright. When you put it to test mode, all the lights within the flight deck go to bright for 10 seconds, then dim for 20 seconds. When it's on auto, the computer, the CCR, Common Computing Resource Software, will basically auto adjust the lighting system. Then bright is bright. Okay, now shift your focus to the left side and look at this cluster. Overhead panel is the intensity of the background lighting. These are going to be your dome lights, captain and first officer. Now the storm light button is also another interesting one. It decreases the lighting, the ambient lighting, and the flight deck lighting. When pressed, it will turn all the annunciators to bright. And last but not least, the master bright. I think all of you can guess what it does. It is the master control. You want everything to go full bright. That's what you turn. You can adjust or just push the button that's in the center and everything will go bright. All the displays, all the buttons, everything. I think I'm just realizing now, I think I may have bitten off more than I can chew on this one. It's okay though, we're gonna keep on going. I miss a button here or there, let me know in the comments and I'll try to explain. Wiper. That is your windshield wipers. You have 3 settings: intermittent, low, and medium. Right below it is a button for the windshield washer fluid. Washer fluid can only be used on the ground when it's raining and on taxi speeds. They don't use that when they're flying. Wipers themselves also have a limitation. They could use it on taxi speeds, takeoff and landing, and at certain flight speed. If I remember correctly, I think it was around 230 knots. Anything beyond that, you're gonna break the motor. I'm not 100% sure on that one. I'll get back to you with that. Little button on the left that says L HUD bright. That's to adjust the brightness of your heads-up display. Be an airplane mechanic, they said. It'll be easy, they said. Yeah, right. It's okay, I still love it. Let's keep on moving. Okay, now let's get into the fun stuff. What we're looking at is the electrical panel. From top to bottom. IFE, passenger seats, your in-flight entertainment, passenger seat power. Cabin and utility will cut out majority of the non-essential power from the cabin, as well as the galleys. By the way, the airplane is smart enough to load shed all of this automatically if need be. Battery switch. Battery switch is connected to not only the main ship battery as well as the APU battery. The battery switch must be on in order for you to turn on the APU, which is the switch to its right. Once the APU is running, you can turn off the battery. It doesn't need it anymore. The APU battery will charge itself when the battery switch is engaged. 2 buttons below the battery switch are the APU generators. There are 2 of them on this APU. Why? Because why not? Redundancy is a fun thing. Also, the airplane is an incredible power hog and it always likes its own power. Below that, you're going to see 3 more buttons: left, right, external power, and then aft external power. Yes, that's right. The 787 has 3 external power ports. This is ground power. Now, you can get the airplane up and running with 1 external power port, but you're going to get the bare minimum. Everything else will be load shedded. It's always recommended to have 2 power ports, which are on the front of the aircraft, left-hand side. But you ask yourself, why do you need that 3rd power port, which is behind the left wing? Well, to answer that question, you're gonna have to look at the buttons down below. As I mentioned before, this aircraft is an incredible power hog. Not only does its internal systems require a lot of power, but also the engines require a lot of power. Why? Because the engines start on electrical power. Each engine has 2 generators. To be more specific, electric generators called VFSGs, variable frequency starter generators. Get enough power to start those engines, you're gonna need that 3rd power card. I mean, you can do it with 2 power ports, but the airplane is going to be struggling. This is why it's recommended to have that 3rd power card to get an engine running. Now, that being said, let's go back to the electrical panel because there's important things within the generator switches itself. You're going to see 8 switches right there. 4 of them are unguarded and 4 of them are guarded. Now, here's the difference. The top row, the 4 of them, 2 per side, are electrical disconnects for the generators. The bottom row is the guarded switches. Those are the physical disconnect. If I wanted to take a generator offline electrically and then re-engage it later on, I could do it with those top 4 row switches. On the bottom row, if I were physically to lift the guard and press one of those switches, that's it. That generator is dead. You can no longer re-engage it. You can only re-engage it on the ground. In flight, that is called a irreversible action. Okay, moving on. You know what the real fun part is? This is just a 787. I have 3 other current fleet types that live rent-free in my head, just like this. I'm not even mentioning the stuff that I'm not current on. Up next, the primary flight computer toggle switch. You got 2 options here. Automatic and disconnect. In automatic, the airplane will be in its natural state. The computers will basically take care of everything. You hit that disconnect, you're gonna go into direct mode. Remember, there's 3 modes: normal, secondary, and direct. Direct mode, you're flying that airplane with no augmentation. Airplane is no longer helping you. You have direct control. Above that, you have your IRS, your inertial reference system. I'm not going to go too deep on this one. It's basically to align the aircraft. Airplane knows where it is. Airplane knows where it's going. Now, the button on the left of the IRS knobs is the more interesting one. Heading reference. Why is it interesting? Because as soon as you hit that button, the switch is a manual way to change between magnetic north and true north. When the heading reference switch is in a normal position, the AFF auto flight function uses magnetic north for its heading reference. When you press that button, it goes into true position. It uses the true north for heading reference. And by the way, when it's in normal mode, the airplane will actually do this on its own automatically. It will change between magnetic north and true north whenever the airplane is in a pole region. But the feature is still there if the pilot chooses to go into true north position. Don't ask me why, that's pilot stuff. I'm just a mechanic. Okay, moving on. Hang in there, we're almost done. No, I'm just joking. We're nowhere near being done. Cabin chime button, passenger sign, off, auto, on. I think that is very basic. You guys all know this. Let's go to the fun stuff. Hydraulics. The 787 is equipped with 7 hydraulic pumps, left and right electric pumps, 2 center electric pumps, 2 engine-driven hydraulic pumps, and everybody's favorite, the RAT, the ram air turbine. A nice little comparison to you between the 787 and the 777. The 777 has 9 hydraulic pumps, left and right electric hydraulic pumps, left and right engine-driven pumps, but the center system on the 777 is much more interesting. It has 2 electric hydraulic pumps and 2 air-driven pumps, and the RAT. Coming back to the 787, one of the most unique portions of the hydraulic system, that it runs on a 5,000 PSI system, unlike the conventional other aircraft that you will see that run on 3,000 PSI. And I know everybody wants to see the RAT. Here we go. This is what it looks like on the 787. Okay, we move on forward. Window heat. This one is very basic, not much to this. There are electrical elements embedded into the window panes. Remember, windows have multiple layers. In those layers, you have electrical wires. You have a primary and you have a backup system. Window frost is a thing at 41,000 feet. Visibility to pilots is very important, so it's not like they can pull over and scrape off some of that frost at that altitude. That's why you have a redundant system. Notice the backup system is for the left and right forward side. That's for the windshield. Primary side not only does the forward, but it also does the side windows. And another little fun fact, not only does window heat prevent icing on the windows, it also makes the windows a bit pliable. So in case, let's say, you do have a bird strike that hits the window, it's a bit more flexible and it will not shatter. The more you know. Moving on. From top to bottom, the battery test switch right there and the towing power. This is a very specific thing. You can tow that aircraft completely dead and only on battery power. Will energize only certain things such as your brakes. Because remember, the brakes are electric on the 787. If you press that test switch, it will give you an indication of high, medium, or low of the battery power. Right below the towing power switch, you're going to see the CCR reset. This is commonly known on the 787 technician side as don't touch that button. CCR stands for Common Computing Resource. It's the brains of the operation for the 787 and directly connects to the CCS, the Common Core System. You push those buttons, you are going to kill the brains of that airplane. It's only meant as a last resort to reset the computer system. That's why it's a guarded switch. Same concept goes for the switch right below it. Passenger oxygen. Normal operation, if there was a massive decompression within the cabin, the oxygen mask will drop automatically. But let's say if there was an emergency and pilots needed to deploy the masks manually, you would press that guarded switch right there. It will deploy all of the masks within all of the cabin. You will get a lovely rubber jungle just like this. Up next, we're going to take a look at the little switch right next to the passenger oxygen, which is the service interphone. It's simply an option to turn it off or on. But to the left of it is the more important one, emergency lights. On the ground, we will have it to off. When the toggle switch is down, it goes into the arm position. In case there was a loss of power within the cabin or aircraft systems, all the emergency lights will automatically come on. Or pilots can physically put it into on position. Maintenance can also do this for testing purposes. Up next, this little knob that says ground test normal, data loading, and enable. This is strictly for maintenance. When you see me doing operational checks within this aircraft, sometimes it tells you to enable the system in order to perform the maintenance. The data loading / enable is to upload navigational data or any kind of software into the aircraft. To the right of it is the CVR, the cockpit voice recorder. Test or erase. I think this one's pretty self-explanatory. You can test it or you can erase the recording. There's a very interesting feature within that system. You cannot erase any kind of voice recording if the engines are running or the aircraft is in flight. You can only do this on the ground. The airplane is the biggest tattletale in the world. You can lie to me all you want, but the airplane will always tell me the truth. Down below that, you got the cargo fire arm, forward and aft cargo pit, as well as the fire handle for the APU. If there was a fire in the cargo, you're going to get lots of bells and whistles. What you're going to do is arm those bottles, lift up the guarded discharge switch, push, and you're going to extinguish the fire. Left of that, you have the APU fire handle. Once again, if there's a fire in the APU, everything is going to light up. What you're going to do is pull that handle and then turn it to discharge the bottle. The push button on the side is to test the fire system. Down below this is the engine panel, and you're going to see left and right EEC mode switches, which are as well as guarded. Usually the EEC is in its normal mode. EEC standing for electric engine control. When you push these buttons, it's going to go from normal mode to alternate. You have to remember, everything's got to do with redundancy, and EECs have a backup. They run on dual channels. In normal operations, pilots will never have to touch the throttle quadrant. The computer will basically take care of everything, but in case something does go wrong, pilots can disengage the EECs and manually maneuver the thrust of the aircraft. Right down below that is the left and right start and normal switches. Now, if this was a conventional aircraft, these switches will be directly talking to the starter and the starter valve, which, again, with a conventional aircraft, that would be a pneumatic system. With the 787, it's an electric start. So those switches don't talk to starter valves or starters themselves. They're now talking to the VFSGs, the variable frequency starter generators. Fuel system, let's go. This one's easy. From top to bottom, fuel jettison. Once again, guarded switches. Arm the system, you select how much fuel you want remaining, you lift up the guarded switches and you press the buttons and it dumps the fuel. Nobody likes an overweight landing. Down below that, you have your fuel pumps. Left, forward and aft, right, forward and aft, and 2 center pumps, left and right, as well as your cross-feed system. Unique feature of the 787 is the balance button down below. It's the only airplane that I know of that has this feature. You press that button, it will auto-balance all the fuel automatically. The reason that you see the aft left pump that is not illuminated because there's no pressure signal on it because the APU is running. It automatically turns that pump on no matter what. Another little fun fact for you, you don't need the left or right wing tank pumps to be running for the engines to run. If they are not running, the engines will automatically pull the fuel out of the wings via suction. Gravity is a beautiful thing. Back to icing. This is the anti-ice panel. You got one for the wings and you got one for the engines. Leading edges of the wings are an electric blanket. The anti-ice for the engines is the only pneumatic portion on the 787 aircraft. Let me be more specific. On the GEnx, that is the only pneumatic option that it has. It will give bleed air to the anti-ice feature to the nose cowling, the leading edge, to prevent any kind of ice buildup. Otherwise, that engine does not push any kind of air into the aircraft system. The rest of the aircraft system is electric. Air conditioning wise, that's what I mean. Up next, you got your pressurization panel, and it's very simple. The 787 has 2 outflow valves, one forward, one aft. As long as it's set to auto, it will do it automatically. Pilots will never have to touch this. If you push those buttons, you're going into manual mode. That's why you have the switches open and close. The outflow valves are the units that regulate the cabin pressure. If any of the systems malfunctions, pilots have the capability to go into a manual mode. Have to regulate the valves open and close manually. But again, that will almost never happen. But in case it does happen, you have the feature to control it. And since we're on pressure, now let's go talk about the air conditioning system. The air conditioning system on the 787 is one of the most unique things about it. It does not run on any kind of bleed air. It runs on electricity. 787 has 4 CACs, cabin air compressors, electrically driven, but works much the same way as a conventional aircraft within its system. The only difference is it's not taking air from the engines or the APU. It's generating its own power via electricity. To be honest with you, it's kind of similar to your household AC unit. If you have managed to stick around this long, you're going to see a pattern within the switches because everything is set to auto or on. That's how the 787 functions. It is a very automated aircraft. Pack left, pack right, automatic. Trim air valves, automatic or on. Forward cooling equipment, Recirculating fans, all in automatic. Actually, the airplane takes care of itself. Pilot input is very minimal, especially on an overhead panel. The most they will do is trim the temperature control from hot to cold. Not much input needed. I think I'm going to stop right there. I hope you guys enjoy that segment.